So our project is solving the problem of wasted energy within the buildings and home because currently the lights turned on inside the building do not utilize natural and ambient light from the sun. Rather than having unnecessary light from the light source, the automated light sensing smart blinds can sense the amount of light outside the window and in the room and then adjust the angle of the blind to save the energy by utilizing the outdoor light. This way, the light source will not be consuming electricity while there is excessive light coming from the window. This project aims to design and construct light sensing blinds to achieve the goal. As you can see here, first we came up with the idea to just pull the string and release to open and close blinds, but later as we progress, we saw that using the stick adjustment of the blind was better option. So we made a small sample to test it. As you can see, we used a wood frame and put the blinds to make it easier to show and test. We only used the components provided in the lab kit to make the project, and the only thing we bought was a lux sensor.
As you can see, this project consists of 7 important subsystems. The main components were the Adafruit Feather Sense board, the ULN2003 motor driver board, the circuit, the VCNL4040 proximity and lux sensor, the stepper motor, Bluetooth connectivity, and other hardware. Here is a block diagram that illustrates how the components are interacting with each other. The lux sensor reads the light coming through the window and sends its signal to the feather board. The board then takes its reading and sends a signal to the motor, and that will adjust the blinds accordingly. Now here is the working of the project with Bluetooth and sunlight.
Okay, this is our Bluetooth demonstration of closing and opening the blinds. When I click down arrow, the motor turns half step. And it closes the blinds. And then if I click up arrow, it turns counterclockwise and starts opening the blinds up. This is our reading for the ambient light in this room currently. Here's our circuit. This is the light sensor. And we will demonstrate how it works by covering it and uncovering it. As we start to slowly cover it and it gets more and more shade, it starts rotating clockwise and starts closing the blinds. And then in complete darkness as we can in this room, it's fully shut. And when we move the shade, it starts rotating counterclockwise and starts opening back up.
To summarize what we've learned from this term project experience is that working on the different components separately was easier than trying to get the system to work all at once. In our case, we had to make sure the light sensor was working properly with the stepper motor, and then we made sure that the Bluetooth connectivity function was working separately as well. Then combining it, we also ran into some problems. One of the main issues was that the light sensor would work properly with the automatic function, but once we connected the Bluetooth app would sometimes disconnect randomly, or if it was able to work, it wouldn't go back to the automated function. To fix that issue, we kind of mirrored the code and what we've done in Lab 6, where we had to use the encoder on the triple wing with the Bluetooth app, and that helped a lot in our issues and problems. If we had to do it over again, or if we had more time, we would have made an enclosure for all the circuits, including the breadboard and the microcontroller, just to make it more user-friendly and appealing. if this is something that's going to be by your window or some, you don't want just loose wires hanging around. So yeah, that's what we would have done if we had more time to address those issues.